run to the lab?
Well, first of all, I personally don't work with spores, like ever. I've never in my life actually worked with spores. Like I take spore prints and I think they're beautiful and I keep them just like to catalog and be like, oh, now we have that genetic, you know, those genetics. But I personally always clone. Which I feel like is the easiest, and like especially if you're like trying to capture that, right? So the difference, a lot of people I'll get calls like, oh, I'm trying to buy some spores and this and that, and like they know I don't sell spores because they're not on my website or anything like that, but you know, right, the mushroom is the vehicle for the spore. That's the whole point. The mushroom is the fruiting body for it to mature enough for it to sporulate and send out its genetic information, which it's gonna be, and you know, it's gonna be a shiitake, but it's gonna have genetic variation from its parent. And when we take a clone, it's that exact same genetic copy, which means it has like similar like phenotypic and genotypic characteristics. And these are words that many people might not know, but like when we capture something from the wild, you know, and we're like, whoa, that chicken mushroom, that oyster mushroom is like raging. There's like 60 pounds on this like fallen log. It's 35 degrees out. Like hypothetically, let's like make a scenario, right? 35 degrees out. It's raging. This oyster mushroom's like fruiting like crazy. And so therefore, that mushroom is able to like withstand the cold. It's fruiting a lot. It's growing off the specific type of tree. Maybe there's like an oil spill like 100 feet down that way. So it's like we're trying to capture that. And if we take a spore and try to cultivate, we might not get that resilience that we're looking for. So when we clone, we are getting that resilience. And we're capturing the physical characteristics, which like literally is like what phenotypic means, like genetic traits that we can visually see. And how I remember that phenotypic is pH, and you know, physical, like what we can see is, you know, pH as well. So like our phenotypic expression is like what we can see, right? We can see that that mushroom is raging. There's like 80 pounds on a log. It's like surviving cold temperatures. It's like maybe by an oil spill, it's like resilient. But what's happening genetically is that genotypic expression. And when we clone, we get that all, okay? And when we do spore, we might not get that resilience that we want, right? So, but mushrooms change, you know, like the training, like you folks might know that like some people are training mushrooms to eat plastics and oils and things like that. Well, it could be that same mushroom that they're getting, and it's a clone, but they're training, because, okay, so let me back up just a little bit. So when we clone that mushroom, we take like a tissue culture from it. Okay, we're taking a mushroom and we're not taking the gills, we're taking like some flesh from that mushroom. And really that mushroom is just mycelium, just specialized, right? And the way I like to even think about mycelium, it's like a stem cell that can be a sclerotia, it can be the fruiting body, it can weigh and do whatever. And so we take that tissue and we put it on a petri dish, and that tissue will be mycelium again. It'll start running. And we can, if you want to even look, I'll move away, like here's some plates, and it maybe not be super present, but there's some mycelium growing on it. And so that mycelium, without, like, if we just give it regular food, it's going to be what we gave it, right? But mushrooms are amazing and super adaptive and resilient, that, like, we can train them to eat other things or, like, attack certain microbes. So, Trad Cotter, right, he does this, like, this experiment where he, like, swabbed his throat, he had strep throat, injected it into a block of shiitake. Within like 3 days, that shiitake was exuding like all these like metabolites. And he like scratched his head, he's like, okay, let's like do this. And this isn't like a new concept, but like then he'll take that culture of that shiitake and then put it on a petri dish, and say he put them on 100 petri dishes, with each petri dish having a little strep or a little oil or a little hydrocarbon or PCB or whatever we want our mushrooms to eat. and they're all on like 100 plates, and out of each of these categories, only 10 of those plates survived, meaning the mycelium didn't die and was able to like eat it, run through, and start consuming it. Well, that's still a genetic clone of that mushroom that we took, right? But it was able to like express different genetic like expression and change its entire physiology to adapt to that infection or that like noxious like PCB or whatever we're giving it. It's amazing, right? They like literally change quickly. So then Trad or other people will take those 10 plates and say, okay, these are the ones that like were adapted. So he'll take those plates and then make 100 more plates with that culture on there, and then he'll add a little bit more, or add more PCB or like more concentration, or add more strep or a different pathogen, and whatever survives, right, is brought in and like cultivated more. They're so cool. They're so cool. It's just like they literally can change and adapt, and it's amazing. It really is amazing. And like stuff like that, like, you do need a lab for, okay? But we can still capture that mushroom from the wilds. Even if we don't have a petri dish in the field, we can bring it back and do the clone in front of the HEPA filter, or we can take that mushroom and bring it home, get some cardboard that doesn't have like colored inks or plastics on it, soak it for about an hour, not even, take out of the water, open it up, right? Most cardboard has that corrugation, right? Take your stem butt of that mushroom, or some of your, like a tissue or something that's not of the gill, and roll that up in your little burrito, with your cardboard burrito, and then put that in a little Ziploc bag. And you could wait for that whole thing to get myceliated, or you can wait just like a few days and let that mycelium jump to that cardboard. And then you can take that cardboard and bring it to the lab and add that cardboard little piece to your agar plate. And then you've captured that. But you've kind of given yourself time where it's like, I can't get to the lab for 5 days. How am I going to capture this? This is like an amazing culture. I want to like grow this, whatever. Well, we can roll it onto some cardboard. And that's for any saprophytic mushroom.
I've tried that a couple times and it didn't work.
What kind of mushroom?
Oyster.
That's
don't
surprising.
I don't know
honestly.
why. Once I thought, well, maybe okay, so once I thought, well, maybe it was too warm, so I put it in the fridge, because I read somewhere that you should put it in the fridge, and neither time did it work.
Sometimes it depends. Like, so if you're gonna like, and I'd love to hear what you think as well, Jay. Where it's like sometimes like, they say to put in the fridge because that stem butt or whatever you're putting in, like, will start rotting.
Yeah.
Right?
Yeah.
But if you're not gonna wait for it to like completely consume, and you're just gonna like, all right, I'm gonna let it like jump, and then I'm gonna bring it, it won't like really rot too quick, because most of the mushrooms that we might want to like reproduce are like, they're not like inky caps, like, disintegrating in like 24
You know what?
hours.
I don't think I didn't soak it. I just got it wet.
Yeah, you want to soak it. It's not just like a quick dunk. You want to like definitely like get it in the water for
How long would you say?
I'd say like at least 20 minutes to like an hour at the most. But what do you think?
In my experience, the oysters have been pretty resilient as long as they don't get too hot. If you're like within some medium temperature, I haven't really ever put them in the fridge to do that, and they usually take off pretty easily.
And how fresh was the oyster you used? I mean, it's not
Yeah, it was. Yeah, they
very
were fresh.
and,
Yeah,
young.
yeah.
That would
got
be
it.
bad luck then.
Oh,
Is there
yeah.
any gas exchange? Do you need to have like air circulation?
I mean,
in the
like
bag?
some
Yeah,
people
maybe.
like some people will like use the Ziploc and then stuff a little polyfill at the end and like close it tight. But I personally have had like luck not doing that as well. But that's a good way to like clone any mushroom till like you show up to a friend's lab or send it to your local mushroom farm to try to cultivate it, and then we're also like preserving these genetics, and we're cultivating regionally adapted species, and that's always the best, honestly. Like, you know, I've had dozens and dozens of cultures like come through our facility, and like really the ones that like came from like a 300-mile radius did the best versus like stuff that came from spawn suppliers on the West Coast or like Midwest or something like that. So it's just my 2 cents.
Would you want to pasteurize that corrugated cardboard?
No.
Or no? Okay.
No, I mean, sometimes, a lot of time, if you wait a while, like, it does get contaminated. But, like, I've definitely had, I don't know if I have it with me, but I have, like, a few that, like, is just a mess of white. It's, like, not even, like, cardboard anymore, but it's just there, and it wants a new home. But I haven't given it a new home. But it's, like, completely there, and it's, like, been there for months. But sometimes they do get sick, you know? It's just... I think it's just like a way to like to preserve it till you're able to
Put it on a plate.
put it on a plate. Yeah.
And usually it's a lot more resilient too because it's already from the wild environment. It's
Yeah.
like dealing with all the bacteria.
Exactly.
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 Is it worth going through the trouble of using distilled water in your lab versus tap water? Say?
Like to soak substrate or something.
Anything really? Is it at any point worth it to use distilled water?
Every substrate that we like soaked was with city tap water. I guess, you know, I think the most important time to like maybe like not have like crappy waters like when you're watering your mushrooms and like misting. You know, like when you're fruiting, maybe it's not the best to like have city water like spraying on them like all day. It could inhibit. However, I know plenty of farms that don't do that. They're just like, it's tap water and it's fluoridated and chlorinated and whatever. I would only like dechlorinate at our farm. You know, we would have like big IBC totes that they're like around here, like those really big ones that have the metal cages, like the 250 gallons. You know, fill those up with the air stone, like pumping air into it, like so it's like literally moving, not like a fish tank one. You know, obviously for 250 gallons, it's a lot of water, but like air stone moving that water so it doesn't stay stagnant or anything, and then using that dechlorinated to water the mushrooms or like to mist for the fruiting room and stuff like that to fruit the mushrooms or to mist the mushrooms.